Imagine walking across Earth millions of years ago. The air is warm. Dense forests stretch as far as you can see. You hear something moving behind the trees. A gigantic creature steps into view. Its legs are taller than a human. Its body stretches for dozens of meters. This isn't a monster from a movie. It's an ancient animal. During the age of dinosaurs, some sauropods became unbelievably massive. Argentinosaurus, for example, may have reached around 30 meters in length and weighed tens of tons. That's like having a living animal as long as several cars lined up together. But here's the strange question. Why would evolution create something this enormous? To understand that, we need to look at the world these giants lived in. One major reason was simple: food. Many of the largest dinosaurs were plant eaters, and prehistoric landscapes could be packed with vegetation. Ferns, conifers, cycads, and other plants covered huge areas. A giant herbivore could spend much of its life simply eating. And these animals had another advantage. They didn't need to chew every piece of vegetation like modern mammals. They could swallow plant material and let their digestive systems process it. Imagine eating almost constantly and having an enormous body capable of turning all that food into energy. Over millions of years, natural selection could favor larger individuals. A larger body could help an animal reach higher vegetation, travel farther, and survive attacks from predators. And once an animal became huge, predators faced another problem. Imagine being a predator millions of years ago. You spot a young herbivore, easy target, but then you see its adult relative. It's several stories tall, weighs dozens of tons, and has a tail powerful enough to seriously injure an attacker. Suddenly, dinner doesn't look so easy. For many large herbivores, size could act like armor. The bigger they became, the harder they were to kill. And some could reach food that smaller animals couldn't. But dinosaurs weren't the only creatures that became enormous. During the Carboniferous period, atmospheric oxygen levels were significantly higher than today. This may have helped some insects and other arthropods reach remarkable sizes. Fossils show giant dragonfly-like insects with wingspans approaching 70 centimeters. But there's an important detail. High oxygen doesn't explain giant dinosaurs. Different animals became huge for different evolutionary reasons. Food, climate, body design, competition, and predators all played a role. And here's where the story gets even more interesting. Gigantism didn't end when the dinosaurs disappeared. Millions of years later, Earth produced giant mammals too. Mammoths, giant ground sloths, and Paraceratherium, a gigantic relative of modern rhinos that may have stood around 5 meters tall at the shoulder. So evolution clearly didn't stop producing giants. But being enormous comes with a serious problem. You need enormous amounts of food. A small animal can survive when resources become scarce. A giant animal can't simply eat less forever. If climate changes, if vegetation disappears, or if an ecosystem becomes unstable, giants can be hit especially hard. It's one reason extreme gigantism is relatively rare today. But don't think Earth has forgotten how to build giants. It hasn't. There's still one creature that puts every dinosaur and land mammal into perspective. The blue whale is the largest known animal ever to live. So perhaps the real lesson isn't that ancient Earth was simply a world of giant animals.